Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for choosing IT Pro TV, empowering the world through engaging learning. I'm your host, Zach Memis, as we continue on with compTIA Net Plus. And for this episode, it's OSI Model. And we've asked our IT expert and all-around great guy, Wes Bryan, to help us out. Wes, good to see you, sir.
Hey, Zach, thanks for having me back. That's right. We're going to throw acronyms at you, and we're going to put them right there in the title to confuse you, right? We're going to talk about something that was actually started back in 1984 and is still around. We're going to dive into a little bit of the theory in this episode. We're going to be talking about a structured set of rules for communication known as the OSI model.
And Wes, right off the bat, I just would like to ask, what is the OSI model?
Yeah, Zach, that's kind of interesting. I'm going to go ahead and throw you a curveball on this one and tell you that the OSI was made by the ISO, right? Boy, if that's not confusing, I tell you. Actually, back in the, if we take a trip back in time, right, and in the early days of networking, everybody, all these different vendors, they were coming up basically with their own rules, right? They were making it up as you go. Not really. They were brilliant, brilliant engineers, but, if you were with one vendor, you had to stay with that vendor, and you would get vendor locked. And again, really wasn't a set of standards. So the International Organization of Standardization, I know it sounds like they can't even standardize their name, right? ISO, and the OSI there, right? But International Organization of Standardization, the ISO actually stands for, it's a shortened form of a Greek word called isos, which means equal. But they said, let's go ahead and we'll come up with a way, a structured set of rules, if you will, and architecture that will kind of standardize the way we do network communications. So they came up with a 7-layer abstract model. They're abstract layers, if you will. A 7-layer model that would really do that. It would standardize the way we communicate between end systems or endpoints within networks. And it also allows, well, just like anything that we do when we do standardization, right? We do standardization. Why? Because it allows interoperability. And actually, you as the customer, myself as the customer, typically, we benefit from that, right? Because if we know that somebody is following a standard, then really the only thing I have to, make a choice from is which vendor is making a better product, right? We know that they're going to be following the same set of rules, the same set of architecture. We just got to figure out who we like better as a vendor. So as customers, we really win out on that. And then the interoperable nature of this means that you can have these dissimilar systems that can communicate, again, as long as they're following that model. So the OSI model is actually a 7-layered system, and again, abstract layers that, again, standardize how we communicate between source and destination across a computing network. Now, we have to know a little bit about those 7 layers for our exam. We got to know some of the, each layer, what the layer is doing, some of the protocols that you could potentially see on those layers, as well as things like, what are the devices? Because we do have devices that work at these different layers. Now, I keep talking about these layers. Let's go into the layers a little bit more there. Talk about layers. What we're talking about is a 7-layered model. All right, and these 7 layers, each layer assists another layer, right? And depending on if you're sending or receiving the communication, it'll dictate which end of these layers you're on. So really, when we look at the top layer is layer 7, right? And you might say, well, wait a second, Wes, doesn't the numerical system start with 1? Why are you starting with 7? Well, if I'm sending information, I actually start at layer 7, and I work my way down to layer 1. Now, if you're receiving information, so in this case, let's say that I'm sending information to Zach here. When he receives that information, what he's doing, his network adapter really, and the cable or the wireless, radiated energy, if you will, it's receiving the raw bits, right? The electrical impulses, the binary ones and zeros. So he actually starts at layer 1, right? The bottommost layer, and he works his way up until we get to layer 7, where the last thing that's left is the data that we intended to send information between two systems. So that's a little bit about what the OSI model is. Let's talk a little bit more about each one of these individual layers. So I've got a little diagram here, and it could help us out to understand these layers, right? Notice that we have application, right? That's layer 7, and you can see both sides of this, right? I went ahead so you know what layer it is, and it is important because on the exam, when we're talking about the application layer, they might tell you layer 7, and it's up to you as a Net Plus candidate to know that layer 7 is the application layer, all right, or that the presentation layer is layer 6, right? So I've got both of these here, right? So that also, if you're happen to be talking to somebody about it, you know that layer 4, right? That's going to be the transport layer, right? And you just have to understand these. So I'm going to kind of use them interchangeably. You have them here, you see them here. You can always pause the video, and I would memorize this information because there's no telling what questions they might ask you when it comes to the exam. All right, and OSI model is something that I have been known to, hear about questions have come up quite frequently. So it's a good thing to get this under your belt. All right, so let's go ahead, and we're going to start at the top layer there. And what I mean by the top layer, I'm going to say layer 7, right? Because when we send information, this is where we start, right? We start with the application layer. And the application layer is really responsible for giving us access to the network, right? Your user applications at that application layer are responsible for giving you access to the network resources. All right, so that's the very first layer. Some of the examples of the protocols that you would see here, things like file transfer protocol, SMB is one, and I don't have all of them in the list here. There are tons of them, so it is up to you. Remember that we're just giving you some examples here. I would definitely study these protocols that we've talked about so that you know where they sit in the OSI model, right? So we have FTP, right? SMB, we have POP3, right? SMTP, you'll notice these right away, right? IMAP, these are our email servers. All right, so an email application is a type of application, and any kind of network-aware application where you're sending communications, right? That's your entry point into the networking side of things, right? HTTP, DNS, these are all examples of application layer protocols. But then we move down. Now that we've got access to the network, where do we go from there? All right, well, now I've got this data, right? And the application layer has given my data access to the network, but the problem is it's not in a format that the network can really move, right? We want to make sure that our data that we're going to send across this network is in a format that's transparent to the network. I want you to think about another way. Think about it this way. All right, if I have a handwritten letter and I need to send it across the snail mail system, right? Here in the States, the USPS, right? The postal system. I can't just take that letter and throw it in the mail. Now, you might say, well, yes, you can. No, technically I can't, right? I can't get done writing that letter, fold that letter up just like that, and throw it in the mail, right? Why? Because it's not in a format that the carrier understands how to get it from where it was to where it's supposed to be. So we need a way that we format it so that the starting point, the carrier can use it, can transport across the network, right? So the presentation layer is all about formatting. It's like taking the envelope, opening it, and putting your letter in the envelope, right? That's just the start, but at least the envelope or a box or whatever you might be shipping, right? If you're shipping like candy to somebody, right? You might put it in a box, but you need a container that we can now put it across that carrier's mail system, right? Well, that's the same thing with your network communications. I have a letter, I need to put it in a format. I need to start away putting it in a format that the network can understand. All right, and that's where the presentation layer starts, right? Sometimes it's called the syntax layer because, again, it's about the syntax of the network, right? We don't want the network to have to worry about the formatting process, right? So this is the first part. This is where things like data encryption happen, right? This is where things like compression happen. If you are familiar with JPEG, TIFF, GIF, all these formats, right? These formats sit right here. And again, I want you to remember things like data encryption and compression. So that's the presentation layer, right? Now that I've got this envelope, right? Now I got to start making some decisions on how I'm going to send it, how I'm going to set up the communication, and that's where the next layer comes in. The next layer you'll see that we have right here is what is known as the session layer. Now the session layer, you'll see some of the things that I've written down here, but I know you guys can read those, these three things here. I want you to make it easier on yourselves. You can always pause the video and you can look and write these down, but think about it this way. The session layer is responsible for negotiating the parameters end-to-end of the communication, bringing that session online so we can send that information, maintaining the session, and then tearing the session down once we no longer need it, right? So that's what the session layer does. It's part of the communication establishment, defining those, in this case, communication parameters, defining the parameters of the communication, maintaining the communication, and again, one thing that I didn't put up here is actually tearing the communication down once we need it, right? Or once we no longer need it, right? So it's responsible for session establishment. All right, now that we've got through the first three layers, here's where it's interesting. All right, when we get through the first three layers, our data is in a format that it's transparent to the network from now on. All right. Now we've got a package that is ready to go. Now we've got to determine what kind of delivery do we want across that communication session. And in another episode, Zach and I talked about connection-oriented sessions using reliable communication methods, reliable protocols. We also said that, hey, sometimes you don't need all that overhead. I just need to throw it in that blue mailbox and walk away from it, and I know the postal carrier can get it where they need to. Again, sometimes, though, you need delivery confirmation. And the transport layer is where we choose the protocols that are going to be responsible for actually moving our information. All right? Two come into play. So we can take a look here. We can see that at the transport layer, right, it moves the data along the network, and we've got a couple of choices. All right? We've got transmission control protocol. We've also got UDP as well. User Datagram Protocol. Now, I want to take a second. I want you to understand, too, that sometimes it's not so clearly defined which layer of the OSI model certain things sit on. You're going to notice that some will sit across a couple of the layers, too, just based on what they're doing, right? So if it's UDP, transport layer. Why? Because I don't need any connection establishment. But a connection establishment with TCP, imagine where that also starts. It starts at the session layer, right? If you're doing communication establishment, defining the parameters, maintaining the communication, and then tearing it down, guess what? Transmission control protocol is a reliable protocol. It is a connection-oriented protocol in which the session has to be connected first. So it has functionalities that are also on the session layer, but when we talk about it as a transport protocol, it's happening there at layer 4. Now, remember that the transmission control protocol, at this point, what we have is we have that data formatted in a way, but it might not be we might not be able to reliably move it across the network. So what does transmission control protocol do? Not only does it maintain that connection, it will take your data and it will segment it. It'll take it and break it down into more manageable pieces, and then it'll sequence it like we've talked about in other episodes, right? And then as we send that information over to the endpoint, it's going to maintain that communication. It's like your delivery confirmation on that little snail mail that we're sending right now. Now I got to talk to the post office and I have to say, you know what? I want you to transport this across your network, and I want to know when it gets there. I want to make sure that it gets there, and I want you to let me know that it's there. I want an acknowledgement that comes back that says, hey, Zach got that package that I sent him. That's what transmission control protocol is doing, okay? UDP, it's connection list. It's best effort in delivery is really what they call it, best effort delivery. Now at this point, I'm not looking at the post office saying I need delivery confirmation. I'm walking over to the blue mailbox, I'm throwing the letter in the mailbox, and I'm walking away, and I hope it gets there. The difference between the two is one is a little bit more complex because of all the extra stuff that transmission control protocol has to do. UDP, it's not so complex. It doesn't take as much computational power, so if you need things like streaming video, you need fast delivery, UDP is where it goes. Where you know, I'll give you another example. Like for instance, when we do DNS, remember we said DNS gives you access to the network. Well, when you do a DNS name resolution request, you don't care where you get your answer from. You don't even need to maintain a communication, right? I just need to send it to the DNS server and say, hey, tell me where www.google.com is. I have no clue. I don't care where my answer comes from. I just need my answer. So it doesn't have to be that complex. We can attach it to UDP port 53 and send it to the DNS server. However, when you have two DNS servers that are communicating and they're transferring zone information, you don't want that database being corrupted. So DNS, again, application layer, gives us access to the network. But this time, when we get down to that transport layer, actually, it's going to start at the session layer. We're going to do a TCP transport, which means the two DNS servers are going to start that three-way handshake, and they're going to maintain the connection to ensure that it gets there and the zone transfer happens without corruption. All over port 53 again. So again, there at that transport layer, what we're saying is that it's really about what type of communications do you need? All right, so keep that in mind. All right, here we get even more fun stuff. This is where a lot of the action happens, and this is the networking layer. If we can take a look here, the networking layer is responsible for forwarding your packets. It's responsible, if you will, for routing. It's responsible for addressing as well. Right? When we talk about IP addresses, and we talk about that in other episodes, well, guess what? IP addresses get attached at the network layer. Now I've got this envelope, but I can't do anything with it, right? I don't know where it's going. So what do? We put a mailing address, right? And we put a return address. Now I know where it came from and where it's going to. Well, IP says that. Let's go ahead and take that data packet. We'll add a header on it, and it's going to have the source IP address and the destination IP address. We can hand it to the router, and the router is going to use routing protocols to make sure that it hops through the networks and gets to the right location. Great stuff, right? So we have some examples of some protocols that you see here, and these are just a few. Right? So for instance, you have IP, ICMP, the Internet Control Message Protocol. Hey, slow down there. You're sending too much information too fast. Right? Flow control, control message protocol, right? And many other things like diagnostics too. Things like OSPF, right? The Open Shortest Path First. That's our distance vector protocol. I'm sorry. Open Shortest Path First, link state. Routing protocol, RIP version 2, the next one I'm looking at RIP version 2, right? That's our distance vector protocol, right? BGP, border gateway protocol, it's what we use to basically send information between autonomous systems across the network. It's a path vector protocol. But there are other ones there too that I haven't mentioned. RIP version 1 is there, EGIRP could be here as well, you know, that's Cisco's proprietary routing protocol. What else do you have? ISIS as intermediate system. So there are more. We don't want to leave you hanging and think this is all of them. This is just some of the more common ones that you might see. Now, here's one that gets a little confusing. If it hasn't been confusing with theory already, here's where it gets really confusing, right? The data link layer, layer 2, or maybe we should say layer 2.1 and 2.2. Why is that? Well, the data link layer, there came a point when they said, you know what, there's a little bit more happening here at these layers than just a single layer, right? So what they did is they came out with, I believe it has an 802 standard, it's 802.2, that's the logical link control layer, right? So they divided it into 2 sub-layers because they figured after a certain point that one layer didn't correctly define what that layer was doing, and it would almost be 2 sub-layers, and that's technically what it is. So LLC, don't let it confuse you. That's the logical link control. When we look at logical link control, understand that this provides addressing, all right? Error and flow control. But this addressing is a little bit different, right? Now we're not talking about network layer addresses. Those are IP addresses. Now what we're talking about are what are known as MAC addresses, media access control addresses. Now be careful because the media access control layer technically is not a MAC address, all right? What it's responsible for is actually controlling how the media, the physical media, which we'll get to that layer in a second, is accessed. That's what it's responsible for, right? It determines who's allowed to access the media. We're going to talk about other technology standards, right? We're going to talk about something known as carrier sense multiple access collision detection, right? A CSMA CD, right? This is how Ethernet would detect, hey, is the media present, right? Remember, how are we going to place the information on the media going down to that physical layer? How is the media there? Okay, I can sense the media is there. All right, I'm going to send my information, and then I'm going to listen again. I'm listening. I didn't detect a collision, so that must have got there. Let me send another frame of information. All right. So it controls things like your carrier sense multiple access collision detection. It also does things like determining frame synchronization. And that's also something to be important. Basically, it determines where a frame ends and where the next frame begins. Now that leads us into the physical layer. Actually, let's make mention, because up here on my slide, I don't really have anything for the data link layer, but let me go ahead and give you another example where you have technologies that operate on both layers. And the reason I say that, notice frame relay, and down there at the physical layer, it actually operates at both layers, right? Because frame relay defines not only things like how addressing is happening and how frames are sent across a switch, it also defines the physical characteristics of the media that connects to it. So it's operating at both. Ethernet. Ethernet is another one, right? Ethernet, we use MAC addresses. Well, guess what? Data link layer, MAC addresses, but Ethernet also, in things like our 10-base standards and our CAT cables, defines the physical transmission media as well. So it's one of those things that you could see, again, at both layers. Your network interface controllers, NICs, right? Your network adapters. They operate at both layers. And I know sometimes there's contention in forums and stuff like that, but if you look at it, I mean, physically, you got a cable that connects to a network adapter, so that's on the physical level. Inside of that network adapter is burned-in MAC address, so technically that's at the data link layer. So it's operating at both. But those are some examples. Switches, and we'll come back to that here in a second. and revisit that, because we'll talk about some of the devices that work on these other layers, because that's also going to be important as well. But Zach is giving me that evil eye, and he's telling me I think we might have to go into a part 2.
Looks like it might happen. OSI Model Part 2 coming your way. Enjoyed Part 1. Wes, once again, fabulous job. And make sure you watch everything in the compTIA Net Plus series. While you're at it, check out the rest of the videos on our course library. Hundreds of videos, all designed to do one thing, take you further. And tell everybody you know about IT Pro TV. They'll be really glad you did. Thanks for watching. I'm Zach Memis.
And I'm Wes Bryant.
And we will see you soon.
Thank you for watching IT Pro TV.